Hello, good morning, afternoon, or evening, depending on where you're watching. Thank you for joining me for this presentation, especially during such special circumstances. I am Arturo. I work as a clinical data scientist at the Integraal Kankercentrum Netherlands. And today, I would like to share with you the work that we've been doing for the past couple of years in developing VANTAGE6, our open source, privacy-preserving, federated learning infrastructure for secure insight exchange. Before starting, let's get this out of the way. The authors of this work have no relevant relationships with commercial interests to disclose. At the end of this presentation, we hope that you will be able to have a better grasp of the concept of federated learning, a novel paradigm for data analysis across data sources, as well as what is needed for its adoption as a mainstream practice. Let's get started. Imagine the following scenario. A researcher poses a research question that needs data from different sources to be answered. There are a variety of reasons for this. For example, the individual datasets might be too small on their own. Perhaps the datasets complement each other and are needed to provide more complete insights, or maybe he or she wants to perform a comparison across databases. Typically, this is solved by generating a copy of each dataset and centralizing them. That is, data are pulled together by a trusted party, combined into a single dataset, and then shared with the researcher so that he or she can answer said research question. This approach works and has been used countless times in collaborative research projects. However, it has some disadvantages of its own. First, the involved parties have to solve the logistics of sharing the data. For each project, data has to be shared with the collaborators, which can become a repetitive and error-prone task. Also, the moment that you generate a copy of your data, you lose control over it. You don't know what happens to it, or if it is shared by the other parties with someone else. Lastly, and most importantly, sharing data, especially patient data, raises privacy and security concerns. This is why regulatory bodies have started implementing legislation regarding responsible data use and management, such as the GDPR in Europe and California Consumer Privacy Act in the USA. In short, the centralized approach brings the data to where the algorithms are. Federated learning is a new paradigm for data analysis. In this case, we turn things around, and instead, we bring the algorithms to where the data are. This way, we can maximize the potential of using multiple datasets for analysis, while at the same time, we minimize the risk of data leaks and privacy breaches. For this end, at IKNL we have developed VANTAGE6, our open source, privacy-preserving, federated learning infrastructure for secure insight exchange. From the beginning, we developed VANTAGE6 with three fundamental principles in mind, which translated into features. 1. Autonomy. VANTAGE6 provides each party with full control and management of their own data. 2. Heterogeneity. VANTAGE6 allows parties to have differences in hardware and operating systems. And 3. Flexibility. VANTAGE6 is able to handle different data partitions. In short, the architecture of VANTAGE6 is composed of a researcher, a server, and a series of parties, or nodes, each of them with its corresponding data. Before this starts looking very complicated, I think that the best way to explain how VANTAGE6 works is with a simple example. For this, I would like to talk about the collaboration that we established with the Taiwan Cancer Registry for studying oral cavity cancer. This type of cancer has a very low incidence in the Netherlands. This is quite the opposite in Taiwan, mostly because of the popularity of the smokeless, chewing tobacco. Once we have identified the parties in the collaboration, the researcher can pose a question. In this case, we wanted to know if there was a difference in survival between the Netherlands and Taiwan. We then sent an HTTP request to the server. Now, among many other things, the server hosts a library of Docker containers. If you're unfamiliar with them, you can think of Docker containers as encapsulated algorithms, packed with all the necessary dependencies to make sure they can be executed in any machine. Of the available algorithms at our disposal, we chose to implement the federated version of the Cox proportional hazard regression, proposed by Lu and colleagues. Then, the server dispatched an image of the federated algorithm container to each party. Afterwards, each party used its own data to compute an intermediate beta coefficient. This aggregated coefficient is sent to the server, where it was updated and sent back to the parties for a new iteration. This process went on and on until the betas converged. Then they were used to obtain the coefficients of the global model. Notice how in the setup the data never left the original location, only an aggregated coefficient. This greatly minimizes the risk of leaking sensitive patient data. This is a summary of the results. We can see that Dutch patients had a larger hazard ratio coefficient compared to Taiwanese patients. Notice how using federated learning, we were able to obtain this type of results using a Cox regression of data located at different places without centralizing them. In the Netherlands, the concept of federated learning has taken the shape of the so-called personal health train. In this analogy, the central server, or the central station, hosts a set of algorithms, or trains, that travel to the different nodes, or stations, while exchanging aggregated statistics. In this framework, VANTAGE6 serves as the backbone, or the railways used by the trains to travel around. As we've shown, VANTAGE6's main focus is to support the development of federated learning projects. However, its architecture and modular components allow different types of applications as well. Namely, we can use VANTAGE6 to set up a fair data station. In this configuration, a researcher could query the node through an API interface. Moreover, VANTAGE6 can also be used to configure a model repository. In this case, access to the data is no longer required. The node could host a model and the researcher could query it to obtain predictions of interest. We want to make VANTAGE6 an accessible and easy to use infrastructure for the federated learning field. To this end, we have built several services and communication channels to support users in the community to set up their own federated learning projects as quickly and as efficiently as possible. We have created and maintain a website, VANTAGE6.ai, where we provide a general overview of the infrastructure. It also serves as a hub for other useful resources. For instance, we maintain a blog, where we publish updates relevant to the community. It also has the corresponding documentation. The website also links to VANTAGE6 GitHub repository, where the users can access the source code, submit contributions, and report issues. Lastly, we have also created a Discord server to encourage communication, interaction, and support between VANTAGE6 users. So what is the message that I would like you to take home after this presentation? I think there are three main ideas worth emphasizing. First, that federated learning is a novel paradigm for data analysis across data sources, in which we bring the algorithms to where the data are. This way, we can maximize the potential of multiple datasets while minimizing the risk of privacy breaches. Second, that we have created VANTAGE6, a flexible, open source platform for federated learning projects that allows autonomy and heterogeneity among parties. Lastly, that VANTAGE6 has been successfully used in the field of cancer informatics, and that we hope that the community will help widespread its use beyond oncology as part of the Personal Health Train initiative. Finally, I would like to acknowledge all the people that have contributed to the development of VANTAGE6 and to this presentation as well, including of course my colleagues at IKNL and our partners at Mastro. I would also like to thank all of our collaborators, with whom we have established exciting research projects across a variety of institutions and numerous countries, with many more on the way. That is all from my side. Please feel free to get in touch via email or follow me on Twitter. Thank you very much for your attention, and until next time.